Hey, I'm here. Just give me about 5 minutes and we'll start the live chat, all right? So just stick around. enjoy my live stream. Huh? What? I gotta go now. Okay, everybody, I'm here. Sorry I was a little late. I figure I'll give time for people to log in. It's just charging the laptop here while I was outside having a quick smoke. It's my second live stream tonight. I think I'm going to be doing more of these. I got a lot of stuff to go over. Any questions you have for me? Hi, Victor. Reefer. I think I've seen Bernie there. Hey, Bernie. Nice curtains, thanks. That's my wife's interior decorating. Yeah, I'm in the bedroom right now. My daughter's going to bed now, so my wife is playing with the chinchilla. All right, I had to get a coffee refill. So it's kind of been a crazy week. I didn't tell anybody, but last Friday they put me on layoff at my job again. So I'm out of work again. Freaking unbelievable. Unreal. Couldn't friggin' believe it. So I got my ROE today. So that's good. I'm able to apply for unemployment insurance. So that's a good thing. It'll give me time to look for another job and see what's out there. Got the resumes out now, so it's just a matter of waiting. I got one job interview tomorrow I'm applying for something a little bit different, same kind of industry, but I'm applying for quality control personnel. So anybody got any questions? We can start the discussion on some of interest. The start of the comments. Okay, let me check here. Attempting Patrick Kelly's tiny generator. Well, let's see. It all depends on what you're doing. If you're doing like Bendini style motor, I heard, also from Doug Conson, I also talked to him as well. He's been making motor generators for a long, long time. Those guys, for motor coils, they're going about 40 ohms to 50 ohms. And then generator coils is 60 to 80 ohms. Now, Henry, I'm not sure in Henry what that is. I would have to I have a LCR meter that I would be able to check out the Henry of my motor coils, but they're pretty high because the coils I'm presently using are at least 1 pound or heavier. The one I have, the largest one I have, is about 1.25 pounds, almost 1.5 pounds. So I imagine the Henry is quite large. Well, the explanation, okay, the piezo stuff, yeah, okay, well, see, basically what happens is in a coil, especially in the pulse motors, even in the Bendini coil, I'm surprised John Bendini never experimented with this. Actually, I'm very surprised he never experimented with it. Maybe he did, but he just didn't tell anybody about it. Because the amount of gains that I was able to achieve using the piezoelectrics with the coil were exponential. Like, they're right off the chart. Like, huge power gain. And all you do is just hook it up to your power in, okay? where the coil is, your positive, negative, and then you just hook up piezos to that positive and negative right where the power is going in, right on the same connection. So it's basically wired in series, or sorry, in parallel, wired in parallel. So basically you have your power coming in here, your coil, it's attached to positive, negative, and then on the other side you have your piezos lined up. I hook those up in parallel, and then you hook it up positive, negative on either side of the coil. That's it. That's all you need. Now the other part of the equation is you have to have a spark gap switch that fires the coil. Everybody's using freaking MOSFETs. Whole purpose is to create a disruptive discharge in the coil. This is where the over unity and the power gains come from. The piezos add to that after. I'll explain that. But I use an automotive relay switch. It's 4-prong. 2-prong is for the actual switch to fire. The other 2-prong is basically a series connection. So power in, power out. You can buy them at Canadian Tire. If you live in Canada, they're about $7. You can go to a United Auto Parts and get them. They're everywhere. Pretty much any place where you get automotive parts, you can buy it. The other thing that I do to that spark gap switch is the armature that fires inside. I take a very thin needle nose pliers. I grab that armature and I bend it towards the contact a little bit more, so I'm advancing it. So now when it fires, it's actually going to fire faster when it's getting triggered by the read or proximity sensor or read switch or whatever you're using. Now, what I like about using that setup is the fact that the power to trip that the armature is isolated from the rest of the circuit. So when you hook up a read switch to it, or you hook up a proximity sensor to it, and if you do it this way, you'll never blow up your read switch because it's isolated from the rest of the circuit. So my daughter just said goodnight to me. Yeah, so that's very important because if you look at the diagrams that you can Google search for pulse motor, they have the read switch in series with the whole circuit. The problem is that read switch is going to be triggering a spark that is very intense. And eventually what will happen, and basically the read switch will fail, which they always do. And that's it. So that's the reason why I use that spark gap switch. Number 2, it's a disruptive discharge. It is not a MOSFET. It works completely different than a MOSFET. A MOSFET does not have a disruptive discharge in it. That's the whole point. That's where everybody goes wrong. Everybody goes wrong. You have to have disruptive discharging switch. Now, if you go back to the plans that Robert Adams said, hold on. Yeah, the piezos are definitely an interesting addition to it. But let me finish the first part first, and then I'll get into the piezos. Yeah, just basically, it's everything is in parallel. So you got your from the spark gap switch, you got 2 wires coming off, positive, negative. Hook that up to positive and negative of your coil. From the coil connections, exactly the same place where you're hooking up the spark gap switch, you hook up positive, negative for the piezos, and then out. Now, I've hooked up 4 of them in series, and I got 2 wires coming off each end, and they go to positive, negative of the coil. Okay, they can be in. I try to keep it in the same polarity because you don't want to screw up the piezo because they'll be firing in reverse. So yeah, make sure your polarities are matching, positive, negative. But going back to the spark gap switch, you have to have the spark. That's where everybody goes wrong. Everybody goes wrong. No, the spark gap doesn't waste heat energy because there's no heat. There is no heat. It's cold electricity. My like if it was heat, okay, and I ran it like a regular disruptive discharge spark gap, it would heat up. But the nature of how I'm firing it, it does not heat up. I put a laser point temperature gauge, and it stays at ambient room temperature. It does not heat up at all. The other way you'll know if you're doing it right is the spark coming off it will be greenish blue. If you got greenish blue spark coming off that gap, that means you got cold electricity. That's the Tesla spark, the radiant energy. That's where the orifice is being opened in time space, allowing that radiant energy to come in. If you have a white spark, that's where you get the radiation, and you also get heat. Okay, so there's a difference. When my spark gap fires, it's greenish blue, and that's an indication that you're getting the right type of energy. So, and honestly, I've never blown up one of those spark gap switches ever. I haven't been able to do it. Like, I put so much power, I put several amps through it is a workhorse. It will not die. Like, you could throw the damn thing against a wall, it won't break. So they're super, super strong. And yeah, I've been using the same spark gap switch for like, I think the last one I bought was maybe 2 years ago. Okay, so with the Adams motor, see, everybody is misunderstanding the purpose of the Adams motor. Okay, the Adams motor, the Bandini motor, any pulse motor, they're not designed to run loads. What they're designed to do is charge batteries. Okay, that's the whole point of these machines. So basically, you're going to have your battery bank and an inverter attached to that battery bank. Okay, the inverter and the battery is what runs all your stuff you want. Then you have your Adams motor, pulse motor, Bandini motor, whatever it is, and that connects to that battery and recharges it. Okay, and it does not run a load. What is that? Then yeah, so what you're going to do is you're going to have two sets of batteries. Okay, one stack of batteries is going to be getting charged by your pulse motor or whatever Adams motor. The other separated battery bank is going to be running your load. So when that power level gets low, you have a set of batteries that are charged now. So what you do is you make a relay switch where it swaps. Okay, so now that dead battery is going to start getting charged by the Adams motor, and then the charged up battery now is going to be running your load. And all you do is just swap batteries back and forth, back and forth. Whenever they run out, just swap them. So I'm going to be working on a circuit where I can get two banks of batteries running. Well, one's getting charged, the other one's running the inverter. And then when the power level gets low on the inverter, all I have to do is flip a switch and they'll swap each other. And then the dead battery is going to start getting charged by the Adams motor. And then the fully charged battery will run the inverter. And that's it. That's all you got to do is swap the batteries back and forth. Now, the advantages of this, the Adams motor, the way I've configured it, it charges batteries way, way faster because you're pumping in negative energy into a battery. Negative energy doesn't create heat. If anything, it gets cooler. So a conventional battery charger will heat up a battery because it's pumping amps into it. It's like brute force pumping power into a battery. Yeah, but you see, yeah, I know what you're saying. It's not that easy, but I've been experimenting with this stuff for a long time, over 5 years. Over 5 years, I've been making these over unit stuff for probably about pushing almost 20 years, right? So there is definitely differences between regular energy and cold energy. So when it comes to changing that battery into a cold energy battery, you get the brand new battery, you have to discharge that battery completely, almost to zero. And then you get your pulse motor and you charge it up right from dead. As soon as you do that, now that hot form of electricity that's in there is now gone. Now you got the cold electricity in there. It's hard for a lot of people to understand this type of power until you actually start working with it. And the properties of the physics of this power is very confusing. Very, at first it's like, what the heck? Why is it should be heating up? It's not heating up. It's a completely different type of power. And until you start working with that type of power, it's very, very hard to understand it. There's a lot of stuff out there about this that explains what you have to do to the batteries. You have to discharge it completely, almost to zero, and then recharge it with the cold electricity. And as soon as you do that, then you just keep pumping cold electricity into it. And the best part about it, too, is because the frequency that it's being pumped into the battery, that frequency now actually regenerates the battery and it creates a vibration within the battery and actually desulfates the plates inside the lead acid battery. Actually, John Bandini talks about that quite a bit in some of his old videos if you watch it. When an inverter is hooked up to the battery, when it is discharging 10 amps, when the Bandini motor cannot back 10 amps into the battery. Yeah, because you have to have two separate banks. You can't run everything just on one bank because the amount of amperage that's coming from the pulse motor into the battery is not fast enough to recover it. Okay, we're not trying to reinvent reality here. We know that it does not pump 10 amps into a battery. That's why you have to separate them. You can recharge it faster when it's not under load. That's basically what I'm getting at. You have to have separate banks. One's running the inverter while one's getting charged. Swap it when the one's finished charged. That'll run the inverter and the other one's getting charged. And you have to do it in that way. John Bandini talks about it extensively, how it's done. Don't think you're going to be able to run 10 amps through an inverter with a battery and have the Bandini motor or pulse motor hooked directly to that battery you're trying to charge and expect it to charge up. 2 sets of 7 comes about 200 euros. What's this? Produces 600 volt spikes, low amps. Yes, and that's cold electricity. But the other thing too is the frequency in which the pulse motor runs at. It's a high frequency, like Tesla coils. They can produce high voltage, high frequency, and a lot of freaking amps. Some Tesla coils can produce 2,500 amps. Now, if it's running at 50 kilohertz, you could actually touch that spark and not die, even though it's got that amount of amperage behind it, because of the frequency. Now, if you had 50,000 volts at 60 hertz at 20 amps, you're a dead man, right? So it's how the power is being modulated. 10,000, 3 meg stacks, design. Well, yeah, it's frequency. Again, when you're talking about the speed of the rotor is what basically correlates the actual frequency. The faster the motor spins, the faster the frequency. See, Well, see, that's a matter of opinion. You can use the MOSFET, but you will not get the results of my machine. My machine will outperform yours when it comes to charging. You have to have the disruptive discharge. You can use the MOSFET, fine, I don't care, use it, but you're not going to get the gains that my motor can. You take the spark gap switch the way I explained it earlier, you bend the armature closer to the contact so it fires quicker. You have to have disruptive discharge, period. And I'll go with that right to my grave. I don't care what anybody says. I don't care. It is disruptive discharge. Yeah, they're not much money like here in Canada, so they're not expensive. They're tiny. They're only about this big. They're 12 volt. One I have can handle, I believe it's 20 amps. So that's more than enough current. Like I don't even have to worry about that because the type of power I'm pumping through it's cold electricity. It does not heat up. And the disruptive discharge is what creates the cold electricity. So when you're building a Bendini motor, hey Bernie, what's up? Well, see, this is the thing. I love to take this thing to market, but the problem is it's all open sourced. Okay, for one. So even if I were to go to the patent office, I couldn't even friggin' patent the damn thing because the stuff's been out there for years. Robert Adams started building the pulse motor that I have. Um, God, 1967, he made his first prototype. 1977, he tried to get a patent. And then after that, he started getting threatened. They denied his patent. He lived in the Netherlands, I believe. He was from the Netherlands. And basically, after he started getting harassed, basically he said that it was already seized by the military industrial complex, and you cannot patent it. So he went into hiding for about 20 years, and about 1991, 92, he's getting into his later years. He said, "Screw it," and he decided to open source all his plans. So they're out there. Just look for Robert Adams. Now, Robert Adams also uses a spark gap switch, but he uses it in a rotary type switch. Yeah, you can add piezos to any of them. The piezos are going to make that coil fire in a different way because when you have capacitive inductance in the coil, that's the reason why my pulse motor for quite a few years would not put out the power that it's putting now, is because of capacitive inductance. All that power is getting trapped in the coil because when you got 2 pounds of coil wire, or a pound and a half, sorry, you got all that power trapped in there. You can't get it all out. It becomes the coil actually becomes a bit of a capacitor. So because of this, you get the condition called capacitive inductance. And if you want to listen and learn more about that, look up Jim Murray and Paul Babcock. They're working on basically the same system. Jim Murray calls it the SERPS system. So it's advanced switching. So they're using high-speed switching where I stumbled on an easy way of doing it without any crazy electronics was the piezo transducers. Actually, I'll show you. I got one here. Hold on. Okay, here they are. That's it right there. Piezo transducer. This one's rated at 30 volts. And I just took off the factory wires. I soldered the wires on myself. These guys, you can get like a pack of 20 for like $16 on Amazon. So these are rated at 30 volts. Now, I've pumped, because it's cold electricity, you have to understand this. This is rated at 30 volts DC. my meter test showing me I'm getting 510 volts spikes going through this. If it wasn't cold electricity, I would have blown the shit out of this. It would be disintegrate. Because it's cold electricity, it's not dying. I haven't blown up one yet because it's cold electricity. If I was using regular DC power through this and I was putting 510 volts off a coil into this, I'd blow the shit out of it. So, yeah, they're buzzards. You know, they even put these things in, postcards and stuff. You know, the ones that make music and all that. They have these in there. That's what makes the sound. These are also pickups for guitars. Yeah, that's what they're an actuator. They can go very high frequency. Now that's why this is getting basically reducing the effects of capacitive inductance in my coil. When I get these hooked up to it, all that power that's trapped in that coil now comes flying out. Let's see what we got here. Yeah, see, I've tried it. I have piezos on this side, I have the coil in the middle, and I got more piezos on this side. I've actually had them on both sides, and they really do help. Yeah, so they're really super cheap. These ones are rated at 30 volts. And I think they go up to, I think it's 30 kilocycles, if I'm not mistaken, 30 kilohertz, 32 kilohertz, somewhere in that range. But more than enough that you need for your coil. And I was spiking 510 volts of cold electricity through this. They don't blow up. So if it's not cold electricity and that was regular electricity, they'd disintegrate. They'd fry. They'd start smoking. So I know it's cold electricity going through it. Any other questions? Oh, we got Bernie in the chat. I don't know if everybody knows Bernie. He's got a Crypto Alchemist. He's got a great channel. Check him out. He's in the chat board right now. He does his shows quite a few times a week. Has a lot of good guys come on and do podcasts with him. So, yeah, check out Crypto Alchemist. Stanley Meyer, yeah. I remember when he died. 1998. May 20, it was May 28th, 1998. Yeah, we'll see. Well, this is the thing. I'd like to take it to get validated. I'm not at that point where I want to go get it validated. Right now, I'm still in the development stage of it. As soon as I build the actual prototype, like commercial model, I think the first one I'm going to make is a 1.5 kilowatt system. I already have the inverter for it. So it's going to be 1.5 kilowatts. It's going to be in a computer server case. It's going to have wheels. We'll have the batteries at the bottom, the pulse motor in the middle and top portion of it. And then the inverter itself will be on the outside of the box, either on the top or at the back. And that one's going to be a 1.5 kilowatt system. And with that, you could probably run a garage or a little lab with it, or a small cabin if you got a cabin. The next model up from that, I have three kilowatt inverters. Every bit will help. I got the Patreon. I got my PayPal donate on my YouTube channel. All the links are there. I even got Bitcoin there. I kind of don't really trust Bitcoin right now. But anyways, yeah, I got PayPal. I got my Patreon. In my Patreon, I got all my schematics, all my ideas. I got drawings in there, videos, anything that's going on in my head, I'll put it up there. Yeah. Any other questions regarding some of the stuff I've done? How many people we got? We got 7 people. Well, it's not that many, but it's good enough for a good chat. So I'm thinking about doing these live Q&A sessions. I'm starting to like them. I like interacting with people. So what electrical load are you able to power? Well, if it's a 1.5 kilowatt system, you could run a small freezer. You could run a microwave oven, providing it's a smaller one. The 700 watt microwave oven would be able to run on it. When I get up to the 3 kilowatt system, yeah, it'll be a lot more robust. Yeah, the information is out there. Like, honestly, that's where I learned. But it comes to a point where you've learned so much on YouTube and reading and stuff like that, is you got to get on the bench. You got to start doing experiments for yourself. It's one thing to see somebody doing it on YouTube. All right. You have to see it for yourself in front of you, and that'll make you a believer. Because when I started this 20 plus years ago, I was kind of skeptical. I was like, well, this sounds pretty amazing. Why isn't it out there? Then you start learning about all the downfalls, with patent office, people getting killed over their inventions. There's a faction, a group out there in the power industry that doesn't want this stuff out there. So I'm thinking, okay, well, if they're killing these guys off, obviously what they have made or created as an inventor is a threat to them. So, yeah, all I could say is just get on the bench, start buying a few components and put it together. Try to follow what somebody else has done, build it right exactly the way they have shown you. Don't try to change anything. Don't try to think you know any better. Just put it together exactly the way they designed it. Then look at the effects, take your measurements, and learn off it. Okay? After you somewhat understand what's going on, now you can start adding a bigger coil, smaller coil, add a piezo to the scenario. Try different things. Start coming up with ideas in your head. And instead of this time, you're going to be doing it for yourself. And you're going to see the effects in front of you. You have to see it happen. Watching YouTube videos all day will only get you so far. I'll give you some background knowledge. If you want to listen to YouTube videos, start listening to Dollard, Babcock, Jim Murray. Those guys are going to teach you a lot. Peter Linderman, all these guys. But what you're going to find out when you get real deep into it, down the rabbit hole, so to speak, is it's going to open up doors to different scenarios. Yeah, the problem is academia has created what is called laws. You got Ohm's law, that law is supposedly you cannot beat. Okay, well, you might not be able to beat it, but you might be able to retard the effects of Lenz's law, or somehow circumvent it and delete the effect altogether. There's always a way around something, and it just takes that one first. Yeah, walls. Yeah, it's walls, not laws. True. I like that. Energy from the Vacuum. Yeah, I've watched the series. It's very good. It's on archive.com. It's called Energy from the Vacuum series. Everybody start watching that. Especially the Bendini, and I'm kind of on the wall with what's his name, The old guy slipped my mind right now. But anyways, yeah, watch that series, and you'll learn something from it. Yeah, I'll do a live demo probably on the weekend. I don't have the space outside right now to do it. Wife's doing some stuff, but this is more or less a live Q&A session. Yeah, you get better footage when you watch my videos anyway. So, just start going through all the videos. You can pretty much start anywhere. I got some Gerard Morin stuff. I got the pulse motor stuff, obviously. Don Smith. There's a couple of things I want to try with the Don Smith device in the near future. And also, I got to get back on track with the HHO stuff. I got to go back on with that. I was doing HHO back in 2004. That's how long ago I was doing that stuff. So I've learned quite a bit about the HHO stuff. So I'm thinking, well, I've got the parts to do it now. And I just got to get on the bench and start putting a unit together. Yeah. Any other questions? Oh, the water, yeah, the water machine. That's another thing. See, like I started off with one thing, and it's kind of branched off into a whole bunch of areas. So the structured water is another one. So the structured water I will be using with the HHO because it creates heavy water, and the effects will be that much greater with the heavy water. So you can Dan Winter. You can look up his stuff. He teaches you about the vortex water. So my machine creates a vortex, that when you pull the drain out in the bottom of the tub and you get that little tornado effect. Well, that's what my machine does. It creates that tornado effect. And it goes through a filter. And I also got the piezoelectrics like this. And I hook it up to a signal generator. And mine's set right now at 528 hertz, which is very good for your overall health and vitality. So I got that going. So yeah, I got the water system. I got like three, 4 different systems I've been working on for the last while. So the Gerard Morin stuff. The problem with that stuff is if you really want to upgrade into a more powerful system, it's going to cost big bucks. So yeah, well, see, a traditional iron core transformer kills cold electricity. Yeah, it's different. It's hertzian. You're switching it from a high frequency, high current to a low frequency, high current, and that's where you get the heat. 60 hertz. You touch 120 volts, 60 hertz out of your wall socket, and you're dead. So the second you introduce a core to the situation, it's different. It becomes the Hertzian type power. Transfer about capacitor, ceramic capacitor. Yeah, like when you're dealing with the high voltage stuff, like the Tesla coil, or if you're getting into the Don Smith stuff, you got to get high voltage capacitors. Ceramic I've been using. I was using 15 kVA, 20,000 picofarad ceramic, or mica. Mica is another type of good capacitor for high voltage. Actually, it's considered one of the best is the mica capacitors for high voltage. When you're using the Don Smith stuff, you're opening up a can of worms. You really got to know what you're doing with the Don Smith stuff. Yeah, hysteresis is never anybody's friend. And the second you add a steel core into the system, that's hot electricity. As soon as you create heat, that's hysteresis. It's the destruction of electricity. That's what Dollard says. The second you get heat, that's it. It's dead. It kills it. And that's where you get the heat. It's the destruction of electricity. And that's how all our devices have been running. Destruction, because the power companies want to make money. In actual fact, if we ran, say, like a street light outside, how much power that does. If you ran instead at 60 hertz and ran it at, say, 200 hertz, you know how much power you're going to save? A huge amount of power. But they don't want to do it because they want to suck as much money out of your pocket by the power companies. Ferrite cores are good, but you still get now quartz is quartz is opening up another can of worms that is very, very interesting. Can you set up a micro grid and upload electricity to the grid and earn money? Well, you can pump that. It depends where you live too. Like if you generate power and you start pushing power back into the system, see with us, what will happen is instead of them paying you money for it, what they'll do is they'll deduct it off your power bill. Here in Canada, that's how it works. So if you're generating power and you pump it back into the grid, then what happens is they'll detect it at the station and also on the smart meters that you're pumping power back into it, and they won't give you money, but they'll give you a deduction off your power bill. Yeah, if you make that system and then you can run your computers and do all the crypto mining you want, won't cost you any money, right? You're generating your own power. But I know the miners, they suck a lot of freaking power. They're power hungry. Yeah, if you can make your system and completely off the grid and hook up your mining operation to it, hey, all the power to you. Now you're making all profit instead of paying money to the power companies. Yeah, that's cool. Solar, if it's working for you, keep doing it. That's awesome. Yeah, if you're completely off the grid and you're running your mining operation, that's cool. That's cool. You're making 100% profit now. All you have to do is buy the hardware. After you buy the hardware and pay that off, then everything you do after that, it's all profit, right? It's just a matter of buying the stuff, making enough crypto to actually pay for the stuff that you bought. And then if you're getting free energy by either a solar system or a system that, like what I made, then yeah, you're going to CB radio, standing wave, tuned with coax lengths. Sometimes coils are needed on both ends, depending on the setup of the radio booster. Yeah, well, the radio is a whole other thing too. Like, radio is something that everybody should learn. I wish I learned more about radio. I was dabbling with crystal radios when I was a kid, so I do understand the concept of the crystal radio. Now, I've been working with a lot lately calcite quartz crystal. If you put anything oscillating next to it, that quartz crystal will absorb that frequency and actually start oscillating. It'll match it. Yeah, see, with the Adams motor, I don't really have to worry about my disruptive discharge because the spark gap is so small that, if I were to put an AM radio beside my pulse motor, I would be able to hear it. But if I went down the street, turned on the AM radio, I'm not going to hear it. It doesn't have enough power to broadcast that disruptive discharge through the air. So, like Faraday caging my pulse motor, I wouldn't need to do it. It's just not powerful enough to actually do it. Now, if my spark gap was, shooting off 11, 12 kilovolts. That's different. You would definitely need a Faraday cage. The pineal gland has crystal within that apparently can act as an antenna. Well, what do you think we are? We're an antenna. Where do you think our consciousness comes from? Our consciousness isn't here. It's from out there. It's a part of the collective consciousness. Everybody's trying to figure out where consciousness is coming from. It's not from your body. We're just a walking radio with an antenna. That's my personal belief. And from what I've researched on it, a lot of people have been studying, trying to find out where consciousness is located in the brain. It's not located in the brain. Our brain's a receiver. Our consciousness is within the collective consciousness, and our body is just receiving that input from the collective consciousness. And after this body goes, all of us are going to die someday. Our mind, our soul, whatever you want to call it, our life force goes back to being part of that collective consciousness. So that's a whole we're getting into a way different topic here. Yeah, like I said earlier about the piezos, start experimenting with them. I got several calcite quartz crystals, and I was wrapping coil of wire around it. Hooked it up to my voltmeter, put one end to the positive and hold with my hand to the negative of it. And I put it with anywhere in proximity of a power source. It will start oscillating. I was actually picking up, I got it as high as 1.5 volts AC coming off the quartz crystal. So pretty interesting stuff. Lithium is okay, but it's unstable. If you want it, the best battery out there right now is the lithium iron phosphate battery. They're very light. They're a dry cell battery. They have a life of like a capacitor. You can recharge the thing like 100,000 times. It doesn't go bad. Problem is a little bit expensive, but when you buy a lithium iron phosphate battery, they'll last like a lifetime. They're extremely good batteries. Lithium ion, they're there. They're using them a lot, which they shouldn't be. They should be focusing on the lithium iron phosphate battery. So they're great batteries. They come, the ones that I get have the BSM built right in them, so I don't have to worry about it. All the lasers in the videos. I've been doing some experiments with time altering, time dilation. That's another rabbit hole that I went down about 3 years ago. I have some other ideas for the time dilation experiments I'll be working on. Which involves lasers, which involves rotating magnetic field, and also high voltage. So you got pretty much everything going on there. All right, we got a pretty good crowd tonight. We got 10 people logged in. If you like the live stream so far, give me a thumbs up, everybody. Also, I got my Patreon and my PayPal donate. I want to get more of this projects on the go. I want to start building like the actual really good prototype of the Adams motor, with a metal case and all that. And yeah, I just want to do a really good version of it. It's going to be a 1.5 kilowatt system. So yeah, I got my Patreon. Everything's there in my description of my YouTube channel. Oh, the other thing I forgot to. I'll get to your questions in a sec. I also opened up an account on Instagram. So it's Faraday RND 369. So I'm on Instagram as well. So I set that up today. So it's Faraday RND 369, and that's it. Yeah, I love to have a DeLorean. Yeah, one of my favorite movies of all time, Back to the Future. Okay, it's 10 o'clock. I'm going to scoot up for a quick smoke, everybody. If you guys want to go to the washroom or whatever, I'm going to leave this stream going. I'm just going to scoot out for about 5 minutes for a quick smoke. If you guys have to get a drink of water, go to the washroom, whatever, go for a smoke or whatever, we can do that now. So we'll take a 5-minute break and I'll be back. Okay, I'm back. Yeah, just experiment. You can try dumping power into capacitor banks. I've done that. My Adams motor had 16 volt, 500 farad super cap bank. It ran my Adams motor for 4 hours. That's how efficient my system is. 4 hours on just 500 farad. So I've got it running as low as 30 milliamps current to run the motor. Yeah, you can do whatever you want with it. Dump it into a full weight bridge after it comes off the end. Um, you can do that as well. I hook it up to a full weight bridge and I can charge batteries directly right to it. And I could use the super cap bank to run it, and the thing will run for 4 hours. So I'll charge that battery for 4 hours. Within that time, that battery will be fully charged by the time, even way before that you lose all the power out of this super cap bank. So if your motor, your Adams motor or pulse motor takes more than 50 milliamps to run it, it'll never last. It has to be 50 milliamps or below. What's the most promising out of all the free energy motors that I've worked with? Okay, when it comes to cost, performance, reliability, and versatility, I would say the Adams motor. It is the most versatile. Now, the Bendini is good. All motors have their different characteristics of what they're good for. It's like trying to compare apples and oranges. You know, I personally like the Adams motor. The system that I'm presently working on is giving me the best, highest over unity. I've measured, according to my measurements, I'm getting an 18-to-1 power ratio. Um, that's my personal opinion. Like everybody has their thing, right? You know, some people like other devices. Some people like working with the Gerard Morin device. Fine. Some people like working with the Don Smith stuff. That's fine. Um, my thing is always been the pulse motors. I seem to get the best results. Uh, Pulse 220 volts in parallel to water heaters, 12 kilowatts of heat from around 30 watts input. That's pretty amazing. See, and then you can get into another motor that I found that is big time over unity is what do you call the um, um, sorry, drew a blank here. It's getting late. um, trying to figure out. It'll come back to me in a minute. But yeah, there's so many devices out there. I just found the pulse motors are promising, but you got to build them correctly. And the game changer for my system was the piezoelectrics. You get that in your into your circuit, your system goes way over unity. You'll put out way many times more power than you're putting into it. Yeah, it's hard to get your head wrapped around this stuff. I've been trying to wrap my head around this stuff for 20 years. So, it's this my story started at a very very young age, and a series of events happened to me throughout my life that led me into this direction. Yeah, it is. It's a definitely a paradigm shift. Um, my world changed. Um, there have been a couple moments where my life changed. Yeah, I never thought this stuff was actually possible myself too. I was a skeptic in the beginning, and then these series of events started happening throughout my life, and it got me into this direction. And then I start building the stuff for myself. See, for me personally, I'll believe it when I see it. So when you start building something for yourself, and then you start to see the effects of what you've built are going against all the physics that you've learned in regular academia. Lockridge device, yeah, that's another one that was really cool. It's in the Energy from the Vacuum series. I forget what episode it is, but they talk about the Lockridge device. John Bedini actually has a replication model of it. It's in pieces. He never rebuilt it. That's a big shame. That was another cool device. Yeah, you can look it up online. It's called the Lockridge device. Yeah, it's Energy from the Vacuum. It's on archive.com. Um, just look up Energy from the Vacuum, and I'll have a list of all the videos. There's like 23, 24 episodes of it. Um, yeah, just do a Google search on archive.com, Energy from the Vacuum series. Tom Bearden's in it, John Bedini's in it. Those are the main two guys that are in it. Um, yeah, don't kill the dipole. That's exactly it. That's the one thing that I like from Tom Bearden. There's a few things with Tom Bearden I find kind of sketchy, but when it comes to that statement, I would have to agree with him. If you second you kill the dipole, that's it. Your system's done. Yeah, the Meg device. I've seen that. See, now the Meg device is a later version of what Don Smith was doing. Don Smith made his device about 10 years before Bearden made the Meg. So if you want to know a lot more about it, you have to start researching Don Smith, and a lot of his stuff is kind of very obscure and kind of hard to follow. But that's a Don Smith device. You're really going to know what you're doing. You're opening up a big can of worms with that stuff. Oh, Ken Wheeler. Yeah, I like Ken Wheeler. He's good. If you want to learn about magnetics, that's the man to go to. I think he's pretty much on the money with that stuff. See, the Don Smith stuff, you got to understand too. You're transitioning from cold electricity, and then you're switching it back down to hot electricity. So you got to understand the physics going on in that device. It can be very, very confusing. Well, yeah, meaning by killing the dipole, the second you extract power off a dipole, you kill it. You create a load situation, like in any motor. All right. If you start putting a load on the system, what happens is now the motor starts slowing down, Lenz's law goes into effect, and what happens is now the motor is going to start drawing more current to keep up with the demand. The idea is to get the motor running to the point where you can pull power off it, but you're not creating the Lenz effect. And that's what the Adams motor does. My Adams motor, I literally have to stop the damn motor, like with my hand, actually stop it turning before I put a load on it. But here's the funny thing. The Lenz effect will take effect on my motor if I almost completely stop it, but get this. The load that will be pulled off the input voltage on my Adams motor does not exceed 10 milliamps. Very, very tiny amount. Because the Adams motor only takes 30 to 40 milliamps to run it. So if I put my hand and stop the rotor spinning, it only increases the input current by 10 milliamps, which is absolutely nothing to a motor. So the idea is create a dipole, have it run, and then have a means of extracting power off the dipole without actually having a physical contact with the dipole. You can do this by a perfect example would be like a wireless transmission of power, like Tesla was doing. So if you create a huge flux field around a Tesla coil, now you got the charged particles around the Tesla coil. Now, if you put another coil that's built exactly the same way as the transmission coil side by side, whatever power this is putting out, this now the receiver coil is now going to capture all that power. Now, the thing is, now off this antenna, now you can extract power off it. It doesn't kill this dipole. It's just transmitting power because it's charging the flux field around the device. And if your antenna is in proximity of the transmit coil, you can pull as much power off this one as you want. It doesn't affect the transmitter. That's where you don't kill the dipole. So that would be a perfect example of that. And Tesla understood this over 100 years ago. So, yeah, you're going to have mechanical losses on any motor. You would have to run the thing in outer space in order to have like very, very little resistance. You're going to have wearing, bearing wear. You're going to have air spinning around it, so you got resistance there. There's always going to be mechanical, friction involved. And you're going to have losses, right? There is going to be a percentage of losses in a mechanical device, unless it's in basically a confined, zero G, zero vacuum environment. Anyways, I think we are going to call it quits. A lot of people have dropped off. I guess everybody's going to bed. Everybody's got to work. Yeah, diodes can be used as switching devices. Yeah, experiment with that, especially with the Schottky diodes and Zener diodes. You want to experiment with those. Yeah. Yeah, they can be used as triggers. You have to experiment with the values, especially with the Schottky diodes. They can actually function like a switching device. Yeah, you could do levitated shafts for your motor wheels. Yeah, you can do that. I've seen it done. Yeah, diodes. I have one diode in my system that protects the circuit so the flyback doesn't go back to the main power source. Now, here's a funny thing. you can use the system in a different way where you don't have that diode in there. And what will happen is the flyback that you're getting off the coil will go back to the source battery and recharge the source battery. I made one motor. I hooked it up to a battery that was like 10 volts. And within a matter of 20 minutes, that 10-volt battery went back up to 12 volts. So basically, I ran that dead battery on the pulse motor, and the pulse motor sent the flyback back to that battery and recharged it. There's so many ideas. Like, just what I suggest is you pick one path and stay on it and work on it. So I've kind of jumped from a few devices, but I've been making quite a bit of progress. If I make a lot of progress on one device, then I'll set that one aside and work on one of the other projects that needs a little bit more attention, and then I'll just kind of carry on from there. Yeah, the motor is a switching device. It basically, all the wheel does is set the frequency of the pulsing. It creates the frequency in a mechanical form. A lot of people have been doing microcircuits for years and years. Me, I use a mechanical spark gap switch, and that's the automotive relay switch you can buy from Canadian Tire or your automotive parts depot. It's the little square box. It's right at 12 volts, can handle 10 or 20 amps. I've been using that. I advanced the armature on it so the thing will actually fire faster. But you have to have a spark gap switch. The MOSFET and transistor will not do what my spark gap switch does. And I get better effects. Well, it's the voltage that creates current. Voltage is a result of increased current flow, which translates into amps. If you got voltage, you got amps, right? The more voltage you have going through that system, so when you have a back EMF flyback, that's where the current and the amperage is created. Now it's just a matter of how much power is going through it. If you got a huge coil, say like 2 pounds or 5 pounds or 10 pounds, or 100 pounds, the more mass you have in that coil will pretty much delegate how much current and how many amps are going to be coming out of that coil. Bigger the coil, more amperage, period. So, Newman, Joseph Newman, that's the name I was trying to remember earlier. Newman, his motor is legit. He made a 7,000-pound rotor. Okay. It took 490 volts DC at 50 milliamps to move a 7,000-pound motor. All right. So it's not about how much current you're putting into the motor, it's voltage. And voltage, you need the mass. The mass is what creates power. So the bigger the coil is, the more power on the flyback you're going to get. So he was able to run a pump with it that was pumping 200 liters a minute. So he was creating a huge amount of mechanical power with it. You got a 7,000-pound rotor spinning. You got a lot of mechanical, a lot of power there. Same thing with the EV Gray motor. That's another one that is a very good motor to build if you have the resources to build it. EV Gray motor. You can read up. It's basically a pulse motor that's high voltage. It runs over a kilovolt, 10 kilovolts, whatever. That's the EV Gray motor. It's basically a high voltage pulse motor. And he was getting a huge amount of power out of it and also mechanical power out of it. So Well, we've been going about an hour and a half here. I know it's getting late. We'll do another live stream soon. I'll put a posting on my YouTube channel when I'm going to do the next live stream. I'd like to thank everybody for coming in and joining into the live chat. We had a really good live chat tonight. And Bernie, check out Bernie's site at Crypto Alchemist. He does a lot of great shows and interviews with a lot of guys into the free energy stuff and APEC and all those guys that work on anti-gravity stuff. Thank you everybody for showing up. If you want to support me, I got my links in the description for the Patreon, my PayPal donate to help me get the necessary components I need to make my devices. Check out all my videos, my chats, all the comments in my chat boards and comments on my videos were really good, like really good stuff, good reading. Thanks, John. Thanks, Reefer. Thanks, Bernie. Who else was on tonight? Who else did we have on here? Messi. Samuel, thanks a lot. Wally, thanks for coming into the stream tonight in the chats. Bernie was in here too. What's that? Esoteric Gold, thanks for coming in as well. What else did we have here? Yeah, I think that was it. Yeah, we had a good turnout tonight. We had a good chat. Thanks a lot. I'll do another posting when we're going to do the next live chat. Just come back. Don't forget to share my site with your friends and all your friends on the internet that are into this kind of thing. Click on the share button, share with your friends, spread the word about the channel. It helps, make the channel grow. This last month use on the site. So, and my, I think that impressions on the web are hitting about, I believe almost 42,000 impressions on the searches. So yeah, we're getting out there. We're starting to cover a lot of stuff, a lot of ground, getting a lot of attention, which is cool. So yeah, good night, everybody, and we'll see everybody soon.